Huh?
Of the practice final?
Damn. Yeah, hold on.
Also, if I can't find my other formula sheets, because I kind of didn't keep track of those, what can I do?
Oh, like I said, you can ask somebody near you, hey, can I copy that? Or you can, the video, I took a video of the formula sheet. That's you
Oh,
put
okay,
it on
from
the
one
board.
day?
Yeah.
Okay, gotcha.
So I have a question from the practice final number 11. That's the goodness of fit one. Yeah, I know it sounds like that's the title I would make up, but that's the actual name of the.
Yay, I got one.
Oh, paper rules my life. Okay. Let's see if I can make it so it's- Ooh, shit. I got it right. I don't want that. Ooh, that's a little too much.
That was necessary.
Alright. I think the system is still,
We're gonna do number 11.
okay, there we go, happy medium. Alright, so the question is, number 11, this guy, okay. So, here's the main thing. I'm gonna have to tell you the observations. You're not gonna actually go out in the world and just wait till people do something and then mark it down. I'm gonna have to tell you what the observations were. So you can always fill it in quick. The expected though, somebody asked me that question. Hopefully they're not gonna take this break because I get a lot of people do what I'm about to do. So like I saw 53 A's, so I observed 53 A's, I observed 63 B's, 131 C, blah, 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 right?
Is this from the quiz?
No, this is from the practice file.
Oh.
Yeah. Has everybody got the practice final copy? That wants one?
Yeah. Sorry. I got a million papers.
I think I got you beat. All right. So I'll see people do this, put like a 0.13 there, or something. So a lot of people do this. The main problem with that is the expected needs to be the same idea as the observed. And the observations are the number of grades. So wouldn't make any sense for this to be 0.13. So how do I figure out what goes there?
Percent of the.
Yeah, expect 13% of
342.
342 in this case. I like it. Now, we didn't do that. We didn't do this one last time, did we? No,
No.
I guess not. So let me show you something. This is kind of nice because do you agree with me? That's going to come out to be a decimal, right?
44.46.
So watch this. This is kind of cool. So if you got your calculator, you can put in there all this business. Okay. And then here, this is kind of nice. So I got all that business in there. Holy. Then I can put, for this one, I can put 0.13 times 342, bam. Right?
What did you put in?
Let me try. So what am I gonna put in the expected? I'm gonna put, for A's, I'm gonna put 13%, so 0.13, of means times 342, bam.
Oh, you just gotta do that for every single.
So it's kind of nice. One thing we haven't done with the list yet is you can actually define the cells using a formula. So now I can just keep going, 0.2 times 342, 0.34 times 342, so forth. Well, let me stop for a minute. Is everybody with me? Now, obviously, you don't have to do this in the lists if you don't want to. It's a pretty good way to do it, though.
On paper, do you round to one decimal place? Like on our chart?
You could, yeah.
Yeah. Is that, what do you prefer on an exam?
If these are gonna come out decimal, you really should do in the calculator, so you don't round, you shouldn't round the problem till the very end.
Okay,
So if you round every problem and then you add them all up, you're gonna compound the rounding error, yeah.
understood.
What do I wanna make L3?
L1 minus L2.
Yeah, O's are in L1, E's are in L2, so I'm gonna make it parentheses L1 minus L2 close parentheses squared. That's O observed minus expected squared. Is that cool so far?
You,
And then of course, what do I want L4 to be?
L3 divided by,
L3 over L2.
Yeah, L3, because that's where that stuff is on top, divided by L2, because that's where the expected are. Shebang. And the extra nice thing about, if you do this in the calculator, you can do that list math sum thing, so it'll add them up for you. So if I do quit, and I do list math sum L4, there's my chi-square, right?
wow.
Alright, that's more of a reaction than I thought. Normally the crowd goes, eh. Okay. So that's what we would call, if you wanted to, you could call that like chi-square star, because that came from the sample, right? What's my next step after this?
Graph it.
Be more specific. You
You
wanna
gotta look
find
up,
the what?
chi-squared for 4 degrees of freedom
Ah, so I wanna find the rejection region.
and 1/tailed 0.05.
Now real quick, you need two things to find the rejection region, right? One of them is degrees of freedom. What's the other thing you need?
0.05,
Why is it 0.05? Because
because it always is.
I don't say it is, right? Now, if I said it was 0.01, then it's 0.01. If I don't say what it is, we assume it's 0.05 because that's the most commonly used alpha. So we've seen this number before. This is a very common number because a lot of these are going to have 5 categories for whatever reason. But if you look up, don't say anything. If you have a chi-squared chart, anybody need a chi-squared chart? I have 2 left, I think, in my possession.
Ooh.
Is it going like hotcakes? So, to find this, I want to go 0.05, and then degrees of freedom for this. How many categories?
5.
So the degrees of freedom would be
4.
4. So we've seen this number before, 9.488. Did we make it far enough away?
No.
No. What would it mean? Okay, if I do get in there, what would that mean?
Reject the hoe, support the ha.
We don't have ho and ha defined, so be less specific.
It's not normally distributed.
Nope.
It's
Well, I see in this case, yes, that's a stand-in for normal, but I mean in general. If I make it into the rejection region, that's evidence of what?
expected distribution.
Rates do not follow the expected.
Yes, that the, whatever it is, does not follow the expected pattern.
But they do in this.
In this case, no, I can't say they do. I just say I have not found evidence that they don't.
Oh,
So you would say that evidence part too?
Yeah, you would say, we have not found evidence that these don't follow the expected pattern. It's the equivalent of saying not guilty versus innocent. Not guilty carries with it an assumption that, we didn't get you yet. We didn't find all the evidence, there could be some more, I don't know, right?
Okay.
So in this case, again, you would say, we have not found evidence. This does not follow the pattern. And I happen to tell you that this would be sort of like a normal curve pattern. And again, I can't remember if I told you guys about, most English professors have moved past the double negative being bad. We understand the double negative has a purpose, especially here. We did not find evidence that it does not follow the pattern. It's not the same as we found evidence it does. We can't say that. We can't say that. We can't use a sample to show evidence for something. We can use the sample to show evidence against something. Yeah.
Can we go through 7 on the practice exam?
And just to remind you guys, I have the answer key for all this, right? Okay. It's gonna start to lose all of its meaning.
Everything's so impressive.
So number 7 is kind of freaky. Read through that if you haven't looked at it yet.
For the one we just did, are you comparing the 6 point something to the 9?
Real quick, going
I'm
back,
confused.
guys, going back to this.
This is the n equals equation, right?
Yes, but going back to this for a moment. What's this point right there?
0.
0.
If I get chi-squared to be 0, and I really harped on this a lot last time, what's the only way I can make chi-squared 0 is if the expected and the observed
Same.
are the same. So that would be so not evidence that they're different, that the population is different from the expected pattern. That would definitely not be enough. If I'm like, I think the average age of gross month students is not 23, and our sample age is 23, that is not evidence that it's not 23. Do you guys agree with me? So 0 would mean the sample followed the pattern perfectly. So not only do I need to see a difference, I need to see such a big difference that it accounts for sample variability. Any sample I take can just naturally be different. Does that make? It's just like hypothesis test where the middle region was what the null thought. So we had to get really far away to show evidence against that. Maybe. So here's something I showed in my other class. Let's see, I need paper. Paper. I got no paper. Paper. What is this? No, I can't use that. Damn it. Here. All right. So let's see. If my population. All right. So what was this about? This was about grades. So real quick, go ahead. What if my population perfectly matched this? So let's say I have 1,300. 2,000, 3,400, 2,000, 1,300. Okay. I want you guys to understand. Do you see what I did? So this perfectly matches the pattern, correct?
True.
So do you understand that these are people? These are the grades of people. 1,300 people made it. So if I randomly pick 342 people from this group, do you understand? The population does exactly follow this pattern, correct? The one I constructed. If I take 342 people at random, does my sample have to also follow the pattern?
No.
Couldn't I just is it impossible that I get 342 people that made a C and that's it?
No.
Is that impossible? No. Is it unlikely as all hell? Yes. Most likely I'll get a smattering of pattern, but any sample I take will naturally not be the same as the population. Whatever pattern the population follows, any specific sample won't perfectly follow that, just because of variability. So again, if all I needed was a sample that was different, I would prove every damn thing, right? And it would suck. You wouldn't want that, because not everything's true. So not only does our sample have to be different from 0, not only does it have to not follow the pattern, it's got to not follow the pattern so much that all the things that could be explained by sample variability runs out. It's like, holy shit, it must actually be different. So, coming back to what we got. Everybody agree with me that the sample does not perfectly follow the pattern, correct?
You.
Yeah, let me put it back up here. These numbers are obviously different from these numbers. Correct? Okay. But are they different enough?
No.
No. So the fact that they're there says it could have been sample variability. We have not found enough evidence that this does not follow the pattern. With
You.
I don't know, okay, I don't know if that helped at all. It doesn't help you with the nuts and bolts of the problem, but this is the idea behind the problem. Okay.
Were we doing this to talk about number 7?
We're coming back to number 7 now. I just had a question from this one, I didn't wanna go past it with somebody not sure about what was going on. Does that help at all? Okay, you're gonna, okay, be nice. So number 7.
N equals Z squared.
Say again? Yes, so, somebody pointed out, since it says, where'd it go? Blah, 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 blah. How large a sample? Okay, what variable is that?
S.
And
Or N.
N.
N, right? S for the standard deviation. So N is the size of the sample, so I want a formula solved for N. So obviously I would never teach this, but now that you've suffered through my derivations, you can start to talk about triggers in problems. If it says how large a sample do I need, that's more than likely gonna be N equals something. And you've got 3 formulas to pick from, and we're in a situation that's got percentages, correct?
Yeah, error bound.
Yeah. So I think Bilal had us going Z squared.
Sigma squared.
No, I guess not.
because we don't have.
Oh wait, what is it? Is this percentages? No. I'm thinking about a different problem. Alright, keep going, you're right.
Sigma
So,
squared.
given a normally distributed population that has a standard deviation of 20, how large a sample should be, blah, 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 blah. Okay, sigma squared over
E squared.
E squared. Thank you. I was thinking about percentages.
19.
Now, real quick. Do we know sigma?
20.
20, right? In fact, they say population standard deviation, right? So that's 20. What's Z?
You gotta look it up.
Gotta look it up. So we want it for a 90% confidence. 1.645.
645, yes, squared.
And then what's the error? What do I want the error to be?
3.
3. So now you just gotta throw all that in your calculator.
19.
That, whatever that comes out to be.
18.49.
18?
18.49.
I would estimate around 70 or something. Let's see.
219.3.
219? Okay.
What's on the bottom there?
That's a 3.
Okay.
121. I believe it should be 121.
120.26.
Yeah, 120.26, which of course you round up to 121, so you don't chop people up into 0.26 parts, right? I want my stats classes to make a bunch of little Dexters run around. I need exactly 0.26. So that is a different problem, but it's, again, the key was the question, how large is sample? Okay, I need an N equals, I've got a standard deviation, I've got a how confident I wanna be, I've got an error, okay, beautiful, I got everything I need, yeah.
So like any problem dealing with like people or like, you know,
Oh, yeah.
discrete things, you would have to round it up, say, cause like we got 120.26 here, so you always have to round it up.
Yeah, because this is so this isn't an average. This is actually how large of a sample you want to take. So if it's 120.26, if that was physically possible, that would make sure the error was within 3. If I go any below that, automatically I can't guarantee it's going to be within 3%. So what do we do instead? Up, because again, I don't want to chop people up, right? Hopefully none of us do. If you do, please take that or adjust somewhere else.
Number 8, Monsieur.
What's that?
8, number 8.
Number 8? Okay. Oh, that's the one, right? That's the question. That's the one that's been on every damn test since we first learned about Z-scores. And I just stopped trying to calculate the percentage you got it right because it was but what does it tell me? So some of you guys will often think that that belongs to the problem before. No, it's a completely different problem, correct?
Mhm.
So it has nothing to do with the problem before, whatever the problem before was in any context. Some of you guys will tell me, it tells me an area. Can you guys just look at me? And if I say Z is 2.14, can you tell me the area? There's 2 problems wrong with that, huh?
9 something.
You can't, right?
You need to have a
Yeah,
mean.
this is
You need to
No.
have a mean to like.
No, you don't.
The Z
Where would you
squared
get the, you would get it from the
From the Z.
Z-squared, right?
yes.
From the chart.
Yeah,
So-
look it up.
But the second more important problem is, did I say it was a normal distribution?
And that's the only time. So even if I said it was a normal distribution, you still can't do it because the z-score doesn't tell me that. The chart does. So what I'm asking you is, what does that z-score tell me directly?
That the point
By itself.
That the point is 2.4
Yeah.
standard deviations from the mean.
Thank you. The data point is 2.14 standard deviations away from the mean or above the mean because it's positive. Yeah.
How do you know to use that formula for n?
Oh, because it was a standard deviation of a population,
Oh,
right? So I knew it was an n equals. I had in my mind it was percentage, but it's not. There's no percentages there except for the 90% confidence. That's what told me my z-score. They gave me a sigma, and within 3 is an e.
oh,
Yeah. So I knew it was one of the n equals formulas because it says how large a sample, that's n. So I want a formula solve for n. Yes.
So again, going back to 7, if the question would have said for normally distributed sample population, we'd use t-score, right?
If we had a normally distributed population and a sample from it had a standard deviation of blah, then we would have used S and T. Yeah. But that would have been weird because you would have nothing to get your T from. Because T needs degrees of freedom, and the problem is I don't know the sample size, right? Okay.
What does LOS stand for in the?
Yeah, what's LOS?
Levels of significance?
Loads of shit. No, what's, yeah, level of significance.
Can
Real
we run
quick,
through 10
guys. Alpha equal to 0.1. Let me see if you guys can just answer this question. Which one is an easier test to get into the rejection region? Alpha equal to 0.10 or alpha equal to 0.01? 1.0. The smaller alpha is, the more significant it is if I reject the null, because it's harder to pass that test. That's why we call it the level of significance.
Can we run through 10 if you get a chance?
No. Yeah. If I get a chance. I'm busy, man. Let's see. Well, all right. Let me ask you guys this. So there was some misunderstanding in my other class. I don't know. There was somebody who seemed to have something. The purpose of this, of course, is for you to try it out. I've got the answer key, blah, blah, blah. So if you want, I have no problem with like picking a problem, everybody trying it out, and then we kind of see what we got.
Yeah, let's do it.
So if you want to try number 10, that's a good one because by this point you might have kind of had some hypothesis tests leak out your brain. So number 10, try to set up number 10.
Good question. This one, you know, the formula you use is the same as this. It's because
Yeah. So I
it's
use
because
this
you-
one, right?
Yeah, but and there you wrote it like this.
Yeah, you can distribute the two if you want to, but
Okay, I just wasn't making sure I wrote it right.
But I actually did this Z sigma over E and then the whole thing squared.
But I
This
got
is just
thrown
distributing
off.
the two.
Okay.
Yeah, same thing. I just like this one better, it's less work to do.
Sergio, number 8, what are you writing?
Huh?
Number 8,
number 8?
please.
What do you mean? 121.
No, number 8.
Oh, 8. Oh, all right.
That was just it's 2 places.
So, like I said, well, what does z-score tell us? That data point is 2.14 standard deviations above the mean.
Okay.
Z-score tells me the number of standard deviations from the mean to a data point. So whatever data point that came from, it would be 2.14 standard deviations above the mean.
So is that whatever unit we're measuring? Like,
Yeah, the great thing about z-scores is how we measure distance in statistics.
okay.
So, you know, like if I want to test a drug and I have a group that gets the drug and a placebo, if I take the difference between the average amount of time it takes for them to work or whatever, then I can tell relatively how big of a difference that is. It's statistically significant, right?
Okay.
Yeah. So I use standard deviations to tell how far things are apart relative to the data.
Are you gonna give us like this much, paper space on the final?
No.
Oh,
Less. I mean, that's a lot. That's too much.
okay, thank you.
You know, my final exams, I normally give it on a grain of rice. So If you didn't get the memo to get a magnifying glass or something, no. You'll have more room on the final.
Like, this is like a page like this, like the packets we get, like 30 pages.
Packets. How do you mean?
Like packets. You know how like with some exams was like 1 page and like flip it over.
Oh, no. It's gonna be the same as any other test I give you, just a little more weighty. So one thing people do on these kind of problems is they totally miss that this is a problem about percentages, right?
The LOS, what is
Yeah, it's gotta be T.
So again, what was LOS again? Level of significance. What is it? What's the symbol we use for it?
Alpha.
Alpha. Yeah. So on the final, I'll probably just say alpha equals, like I normally do. Yeah,
It's the alpha.
yeah. I like loads of shit. 0.05, yeah. So if I don't say it's 0.05, this one I say it's 0.09. By the way, all right, I want to make sure you guys, on the actual final, I'll give you all the steps, right? And I'll give you room, all that kind of stuff. It'll be nice. There's 5 steps here, correct? So make sure. So the first step is claim in your HOHA, right? And then Z or T, and then rejection region, and then did you make it far enough away, Z star, and then conclusion, right?
Oh, this is HOHA?
Tubular. Yes, this is testing a claim.
CL
I'm sorry, here, this is testing a claim.
CI,
Huh?
CI, on 5 years, CI.
The
Nowhere does
confidence
it say to find a confidence interval, nowhere.
Okay.
Yeah, so I would never find a confidence interval in the middle of a hypothesis test. Yeah, 2 totally different things.
I find Z, I find B.
So let's see, I'm gonna catch up to you guys. Use that again. Here, beautiful. So what's the claim?
That the mean is greater than.
B equal
Percentage.
Oh, yeah.
0.0.
Oh, yeah, percentage.
387.
Is greater than.
Where's it? Here we go, increased.
Yes.
Sorry, you can't see that. Okay.
So.
P is greater than 38.7.
0.387.
Oh, 0.387.
P, where do you go? P greater than 0.387, I like it. So like you said, it's gotta go next to the. It's gotta go next to the huh. What goes here?
Equal.
Less than or equal.
You could put equal, I always just make it the opposite, but you could put equal. How many tail tests will it be? One tail, I like it.
So like,
Z or T. Or actually, in this case, I would be nice, I would say Z or nothing. Because remember, with percentage problems, we don't use T scores. Z or nothing. Basically, if you ever catch yourself saying nothing here, you're more than likely making a mistake. Because I wouldn't put that there, that would be so evil, right?
yeah.
Then I'd almost want you to go, I'm not gonna do the damn problem, Jeff. What do I check? N greater than 30, is that good?
NP and Q.
Good. And P, N is,
292.
and P is,
Uh,
no calculation to do, we already know it's
0.387.
grade 7. Whatever the hell that is. Say,
113.004.
113?
Yes, sir.
That's at least 5, NQ, 292 times point,
Whatever 1 minus 0.3.
you get 190,
178.996.
78? Oh, yeah. That's at least 5, cool. And of course, that together means that we're working
Normal
with a
enough.
normal enough distribution.
We use a Z.
So I can use these.
Yay.
Z is.
Z, I like it. Z's dead, man. Alright. So what the hell are we talking about? What are we allowed to use to talk about it? Then we wanna set up where evidence starts. So it's a one-tailed test.
X bar minus mu.
No, we're not doing that yet. One-tailed test up here,
Yeah.
right? What's alpha?
109.
109.
5.
Is that on your T-score chart?
No,
Oh shit, too bad. So you gotta do it the old-fashioned way. Does anyone remember the old-fashioned?
No.
How much is here?
0.01.
How much?
0.045.
No? It's a one-tailed test, right?
0.09.
All of this shit goes in there, right? Okay. So what's this?
1 minus.
0.09.
So look 0.91 up on the Z-score chart in the right place, right? That's the old-fashioned way. We did it before we got the Z-score charts. So if I give you alpha that's not on the chart, then you have to do it the old-fashioned. You guys with me? You look up 0.91, that's an area, so it's gonna be the body of the chart, right? And then you look out to see what the Z-score is.
Can you get the closest thing to it?
Huh?
Should we get the closest thing to it?
Yeah, closest thing.
I said it first.
So it'll be 1.34.
1.34, that doesn't sound quite right. Well, maybe it is, wait a minute.
1.34.
Yeah, 1.35, yeah, that sounds about right. Yeah, it should be right above 1.28, so yeah, 1.34, like. Let me stop for a minute. Somebody, real quick, look at your T-score chart. Look at one tail 0.10. What's the Z-score for that? One tail 0.10.
1.282.
1.282. So if this was 0.10, the tail would be bigger. The Z-score would have been 1.282. 1.34 then makes sense. Tail's a little smaller than that, means the Z-score is a little higher. It makes sense.
How did you get 1.34? What chart did you use?
Sorry?
This is
Oh, Z-score chart. Because the T-score chart's not detailed enough. Yeah. All right, how we all doing?
And you just was looking up 0.91 on the Z square?
That's all I was doing, on the Z chart,
Okay.
yeah.
I got you.
The Z.
Yeah. All right. So now we know what far enough away is. If I want to put it in words, if Z star is
X bar minus mu.
how do I get in here? Z star's got to be greater than.
1.3.
What can we do?
Project the hoe, support the hub.
Reject the hoe, support the hub. Sounds like a good life lesson. I like it. So now we've set up where evidence starts, what far enough away is. We're gonna see how far away we got. So what do we know from our sample? How do I calculate p hat?
You
So
divide.
122 over
Just divide.
290.
Yeah, 122 over 292, what do you guys get?
0.4178.
4178?
And then 0.5822 for Q hat.
We don't need q hat. Where we're going. Sorry. You guys all with me? What z-score formula am I gonna use for z star?
P hat minus P over.
Yeah. No, Jeff. Square root of PQ over N. 4178 minus, what's P?
Yeah, we always assume, the whole idea of a hypothesis test is assume this number is right and see if it leads us to a contradiction. If this really is the right thing, our sample should show up in here. That's the idea. So we assume it is this, and we see if it leads to a contradiction. That's the idea. So we assume we do know what P is, it's 0.387, divided by the square root of 0.387 times 0.613 divided by 292, yes. And then you gotta be able to throw all that in the calculator. Remember, tell the your poor calculator thankfully does not have eyeballs. That's gonna be such a weird time. I predict in about 32 years we'll have calculators with eyeballs. You just point it at problem. I mean, already you can point your phone at certain problems and it'll actually do the math for you. You guys know that?
Yep.
How do we find,
ChatGPT?
p-value again?
Photo math, huh?
How do we find the p-value again?
Oh, we'll get there. We're not there yet. I'll show you. Anybody have this yet? No, okay. Is that what I get? That looks wrong, Jeff.
One
Oh,
point
wow. I
oh
did
eight.
some weird shit.
10285?
I got 1.08.
Yeah, 1.08.
I pushed some weird button. There we go. Yeah, I get 1.08. Yeah.
Yeah.
So I don't know. Take a look. I pushed the wrong button at one point, so that was great. So you got to tell the calculator that this is the top, and then you got to make sure that all of this is in the square root. So if you have the older calculator that has a square root and it opens a parenthesis, do not close that parenthesis until you got everything in the square root. The minute you close it, you're outside of the square root. Did we make it far enough away?
No.
So we already know the answer. But again, in real life, there is no alpha. There is no alpha. So we always do p-values. What the hell is the p-value for this guy? So again, the 1.34 is the z-score for the rejection region. So it's the z-score that goes with this alpha. The p-value is the area in the tail that our z-score makes. Can you find the area in the tail above 1.08? That's chapter 6 problem, right? And you're all like, dude, this is like 6 chapters ago. What do you have to use?
1 minus 1.
Yeah, you gotta use the z-score chart and then do 1 minus, I like it. I don't even know if I have a z-score chart.
1 minus 0.81.
You gave all mine away. So what do you, I'm sorry? Point
8106.
8106.
Oh, no, hold on, sorry.
Sounded roughly right, but.
0.8599.
Is everybody else looking that up? 8599?
Yeah, 8599.
So then the actual p-value will be
0.1401.
1401. That's the p-value. That's a huge p-value. If I saw that p-value, that means they didn't find evidence. That's straightforward. So if I saw a p-value of 0.002, like that's strong evidence. P-value of 0.14, that's bullshit. That's nothing, right? So in the real world, again, we don't have alphas. Everybody comes with their own level of evidence required. That's what alpha really is. Of course, right now, you guys are not really deep in any field. You haven't developed what's enough evidence, so that's why here we give you an alpha. You say, okay, in this case, it'll be this. So you always see p-values all throughout any statistical analysis in any journal article or anything you look at. If it was a two-tailed test, there would have been one more step to get the p-value. You guys remember? For a two-tailed test, don't I take alpha and split it in half?
Yeah.
So whatever's in one tail, don't I have to double it to figure out what alpha was?
Z-score.
So if I have a two-tailed test, I would have doubled that. The p-value would have been 0.2802. So if I have a two-tailed test, I've got to double that number I get to get the p-value. Why didn't we do it here? We had a one-tailed test. Everything's just on that one side. So what was the weirdest part about that problem?
It was last year,
What's that?
it was from last year.
From last year? What?
Oh, okay.
Oh, I see what you mean. Well, to me, it feels like it's about 27 years ago, actually. Also, it feels like it was yesterday, so that's the weird thing about it. All right, everybody got really quiet on this problem. Was it the p-value that gave you the most trouble? What's up with that? So whatever z-score you find, whatever your z-star is, find the area in that guy's tail. That's it.
You
That's
always
it.
want the p-value.
Always no.
Oh, so you might just look for Z-star, and then we can base
It
our-
depends on if asked for it. I told you I would never ask you for the p-value for a t-score test because our t-score chart's not detailed enough. If I use the calculator, it'll calculate a p-value for a t-test all day, and I don't give a shit. Right? Because again, it's doing all its work inside. You know, you don't even see what it's doing, so what use is it to you? None. Okay, maybe.
So then, number 6 kind of goes along the same lines, but we're using the mean instead, right?
It doesn't have to
Yeah,
be-
number 6 is another hypothesis test, except it's for means. Yep. I also give you like a more standard alpha, right?
Yeah.
Yes.
How do you know when something is two-tailed or one-tailed?
Read through number 6 real quick. And pretty much, if you're paying any attention, I just gave it away. Let me ask it this way then. Why is number 6 going to be a two-tailed test?
Because it just doesn't
Just
change.
as-
Yeah.
Doesn't say greater or
Changed.
less.
Has changed. That's not directional. So either direction would actually make it evidence, right? Go far enough up or far enough down. So that's two-tailed. If I see a directional word, we think it's increased, we think it's gone down, we think it's less than it used to be, we think it's more than it used to be, we think it's at least this much. Any directional word, one tail. If I say, I think it is 7, that's a claim, correct? Is there a directional word there? No, it is 7. So that would be equal, so then what would the opposite of that be? What's the opposite of equals?
Greater
Not
than or
equal.
less?
No,
Not equal to.
Not equal.
not equal to.
Oh.
Two tails.
So the claim would mean equals 1.43, the hose mean equals 1.43, and the how would be mean does not equal to.
Exactly, 11. So the claim is mu not equal to, because they think it's changed, right?
Yeah.
Okay.
And we'll use T-scores, right?
YT, yep,
Because
YT.
you have the sample standard deviation.
Well, let's see. Now, wait a minute. The standard deviation they give us in this problem, guys, the standard deviation they give us, did it come from a sample?
No.
Nope.
Came from the population.
The way it's worded,
Oh,
it's assumed to be a population standard deviation, right? Okay.
Yeah, historically.
okay, right.
Historically, blah,
So
blah,
we
blah,
use
that's the accepted standard deviation, didn't come from a sample, it came from just the general acceptance, so that's gonna be our sigma. So we'll be using z-scores, yeah.
And we can give you want a P for that too.
No.
Yeah, I didn't
What
ask
was
for
it?
it, so, but, you know, you
That
could
would
give
be-
me a p-value if I wanted to, yeah.
Times 2.
In this case, it would be times 2, yeah. Because it's a two-tailed test, I love it. Okay.
So we use these for because we have the standard deviation of the.
Two things, we have the standard deviation of population and
And is greater than.
n's greater than 30, so it's normal kick-ass. Okay. So again, today is wide open. We could continue doing problems off the practice final if you want to.
Yeah, let's do it.
We could do problems from a past quiz. We could do problems from homework. You could just generally say, hey, remind me what the shit chi-squared was, you know, whatever. Yeah. Maybe don't say it the way I say it. Jeff, what the shit? Yeah. Oh, where?
Number 3.
Oh, yeah, okay. This problem all right. What is it that I give you for this problem? I give you a list of what?
Probability.
P of x's and x's, correct?
Oh,
So if you look at your formula sheet, it should really jump out at you what formulas you're eventually going to use for this, right? So when I always get people, I always get somebody trying to use binomial, the n, p, and the n choose x formula for this, but no, this is an x p of x problem, right? This doesn't say it's binomial. There's more than 2 possible outcomes, so it can't be bi. Nomio, right?
So first off, is it valid?
Yes.
Why?
Because P of X are between 0 and 1.
And?
the sum of P of X equals 1.
Good, so in this case, it's exactly one. You know, if I give you this problem, I might give you one where it adds up to be 0.9999.
But that's still,
In which case you say the sum of P of X is 0.9999, which is close enough to 1. So you're telling me you checked it, and you tell me what you know it's supposed to be, right? What it's supposed to be at. In this case, it's exactly 1 if you add them up. Is everybody with me? So two things. All the probabilities between 0 and 1, they all add to 1. So you can either say that mathematically, or you can say that in English, like I just did, yeah. Is there a shortcut for part B?
yes,
Totally. What's the only thing that X greater than 3 leaves out?
3.
So that's 11% of my data is 3, so what percent of my data is more than 3?
89.
89%. Or you can just add them all up, it's not that big of a deal. But if this was a list like 20 long, that would be an awesome freaking shortcut. I don't want to add all that shit up. So everybody with me so far?
Yeah.
So what formula I'm going to use for the mean?
Sum of X, P of X?
Yeah, the formula's got X's and P of X's in it, so I need a column of what?
P of X, X, P of X?
X, P of X's. Is this coming back? We haven't done this in a while, I know. So you make a column of X, P of X's, you add them up, that'll be your mean. Right, what's the formula for the standard deviation? Or the variance, let's start there.
Square root of the
Oh,
sum
okay.
of X
Standard
squared P
deviation.
of X minus M squared.
So if I cover the summation symbol, I need a bunch of X squared P of X's. So this will be X squared P of X. So I'm gonna multiply L1 times L2, this times this, and get these. And then I can do, what I do is I do this times this to get that. I don't know if you guys remember that.
Yeah.
This adds up to be the mean. This adds up to be a number that you have to plug here to figure out the standard deviation. And again, it's just a little bit of practice. Now that you've gone through this, it's just like, you just got to do it to shake off the rust that's developed since we've done these kind of problems.
Are you gonna make us do that P25 stuff?
that was 4, right?
That's
That's
the
our-
house.
Oh, yeah, forget about it.
What? You mean like this?
Oh,
No, that stupid,
that was what the
Whisker box
subscripts.
thing. Whisker
Ooh.
box and tails.
Should be calling us stupid. I'm gonna put that shit big time on your final. Your final. I'm gonna make it specific final. It's gonna be nothing but. This could be reverse psychology. You're like, who's yes, I love that shit. Okay. I don't know. I could put box and whisker if I wanted to. Why not?
Number D.
Where are we at? Sorry. Oh, for part D on this.
Yes.
Okay, so for that we need these numbers, right? So real quick, how do I do this in the calculator? I gotta clear out 4 of these things. Then I can put in here 3, 4, 5, 6, 7. Turn this off. Go away. Okay. Put in here 0.11, 0.14, 0.12, Chuck, 0.13, is that what it says?
0.5.
Don't get old, kids. Okay. Then I want this one to be L1 times L2, that'll be X times P of X. And then I want this one to be L1 times L3, X times X P of X is X squared P of X. Bam. You can almost see that. Let me see. That's better, okay. Is that alright? I did a little fast, but I mean, you can do this in the calculator. Now I'm gonna do something, I can't remember if I showed you guys this, but if I do calc 2 varstats, L3 and L4, the reason I don't show this very often is it gives me more information, because what do I want to do right now? Don't I want to add up L3 and L4? So I'm only going to pay attention to the sum of X, that's going to be L3, that's 5.77, and the sum of Y is 35.41. It's a nice quick way to sum up a couple lists. By the way, if you have to leave, don't forget to get a copy of the practice fund answer key.
Oh, they're physical? They're not just on Canvas?
They're not on Canvas at all, it's all on Canvas.
Oh, okay.
Only old school shit. Oh, yeah, let me catch up with everybody. Where are they? Here they are. If I give you any homework back that has nothing written on it, that means it's good. I'm assuming it's good. Yes. Does anybody else didn't get their stuff back? Oh, some.
Is 1.455?
Alright, sorry guys,
Can you get the 2-bar stats one more time?
stat, count, 2 var stats,
Uh-huh.
and then make it L3, L4.
Oh, okay.
The reason I don't show this is because it gives you a lot more than you need. I'm just gonna look at the sum of X and the sum of Y. That's the sum of those two lists. All the other shit doesn't mean a damn thing. Of course, the calculator doesn't know that, it's dumb. So, the mean we get, where'd it go? 5.77. So the standard deviation is gonna be the square root of this minus this squared. Right?
1.455.
1.46.
455? Standard deviation at least 3 places, right? So, how do I do part D?
Take the mean and add and subtract.
Put the mean in the middle,
And add and subtract the standard deviation.
add one of these, that'll take me up to 7.2
225.
something. And subtract one of these, that'll take me down to 4.3 something on it. So what data points did I catch in there? A little TIE fighter here, what data points did I catch? Did I catch the 4s?
No.
Nope. Did I catch the 5s?
Yes.
Yep. Did I catch the 6s?
Yep.
Yep. Did I catch the 7s?
Yes.
Yep. So then I caught 12% plus 13% plus 50%. I caught 75% of the data. Now I ask here, might the data be normal? The easiest way to answer that is look at the actual distribution itself. If it's normal, where should the highest point be?
In the middle.
And where is the highest point?
In the end.
So already I know it's not normal. Also, this should be 68%. It could be 75% and it's roughly normal. So you should really look at the distribution to see it's not normally distributed. Yeah.
How did you figure it's 75% again?
Didn't I catch all the 5s in here?
5, 6.
I caught the 5s,
5,
right?
6, and
6 and 7. So I caught 12% of the data plus 13 plus 50. If I catch the 5s, that's 12% of the data already, right?
Oh,
Okay.
So why is it normal or not normal?
Well, look at the distribution again. To be normal, doesn't it have to build and then come back down?
Yeah.
What's the highest
7.
peak at the tail end? So it goes like that. Not normal. Yeah. So I knew from the beginning this wasn't normal.
so skewed to the left?
This was a little bit weirder, but yeah, skewed. Yeah, it would be skewed to the left.
Can you say why or why not normal because it's skewed to the left?
Yeah, I would accept that. You could also just say the peak's not in the middle.
The data be normal?
It's not symmetric, huh?
The data be normal?
That's what we're talking about right now. No, because the highest peak is at 7, which is not in the middle. So to be roughly normal, it needs to go up and then come back down, right? This one goes, so it's definitely not normal, yeah.
Can you show us how to do C again, number 1C?
Is there anything about this problem here, guys? By the way, if you are ready for the final, you could head out, right? Okay, see a few people on phones and such. If you're ready, head on out. Number 1, what? C?
Please.
Can you guys draw that picture for me? You gotta remember what P95 means. What does it mean?
95th percentile?
And what distribution are we working with? Normal, okay. So all you gotta do is draw a normal curve, and where do you put the 95th percentile? It's gotta have what percentage? Yeah.
Oh,
It's
you
gotta
just
have,
going in.
it's gotta have 95% below it, right? So it's gotta be way up there.
That's it?
No, it's definitely not. So what is this problem about? Remind me, what's this problem about? What's physically? What's the problem about? Physically.
Money, what X is.
No.
Money spent on
This
coffee
whole
for
problem, what's the problem about physically?
Money spent.
The money people spend on coffee,
For
right?
US ago.
So I wanna know the 95th percentile amount of money spent on coffee. I know that's the question from context. That's what the whole problem is about. So have I figured that out yet? Hell, I got it. It's not 95 cents. I doubt that's what 95% of people spend on coffee in a year. Right? So we got anybody drink coffee in here?
Yeah.
Anybody drink coffee like every day?
Okay.
Yeah, okay. I drink, I make my own, well, I don't make my own, I don't have my own beans. But, dear God, if you go to Starbucks, do not calculate your annual spending on coffee. You'll cry. So can somebody look up what that Z-score is?
0.8289.
Is that a Z-score?
Yes. South of Z
Or
score.
Z score would be 1 point.
You assumed 0.95 was a Z-score, right?
1.96.
0.95 is an area.
Damn. Okay.
What'd you get?
1.96.
No?
1.645.
There it is. It's not a 95% confidence interval, correct? It's not chopped like that.
Oh.
So you gotta look at 0.95 in the body, and it's the little asterisk dude, right? Get 1.6 for 5.
1.6.
Dang.
Real quick. Isn't that the 90% Z-score? 90% confidence?
Yeah.
So how does that relate to this problem? Well, if I chop it symmetrically here, what percentage is in this tail?
0.05.
5.
So what percentage, if I chop it here, there'd be 0.05 there, what percent would be in the middle then?
Oh, yeah.
Alright, so that's why, right, there'd be 90 in the middle, correct? So that's why that Z-score happens to be the same thing as a 90% confidence interval, because they both talk about the same damn location. Is that the answer? It's not $1.65, right? That's not what 95% of people spend on coffee in a year. So how do I translate that back into an amount of money?
X equals.
Yes, the
Z
backwards formula.
plus Z score times standard deviation.
Exactly. So we just did everything opposite. Normally, like in number 1, A, you would take that, you would make it into a Z-score, you would look it up in the chart, you would get an area. We just did all of that backwards. We had an area. We looked it up in the chart, went backwards to get a Z-score, and then we used the backwards formula to get back to X.
How do you get sigma?
It tells us.
38.
Yeah.
Oh.
Yeah. Okay, so let me do this. I'm gonna give you guys the answer key. It's a 2-parter, so bear with me.
Did anyone take 220? 0425? Answer key.
Oh shit. You can put one up on your fridge if you want. I'm pretty sure you don't want
Are
one.
these front and back? Oh. Oh, okay.
Yeah, could you remind me when I get back up there?
Let's say, mention some, you know, you can take like a 35-year lifespan. 30? So for the final, we should have the chi, z, and t score charts.
Yeah, you need I, C, and T. Huh?
Dude, I think I have to stop at the master.
What? So again, if I gave you back homework that's got nothing written on it, it's assumed okay.
And then, am I still allowed to turn in corrections like Monday before the test?
Yeah.
Oh, that's done.
Anything, guys, anything you have not turned in yet, any corrections you haven't done, so quiz 1 corrections. If you never did them, you can do them now. You can turn them in on Monday. You're not going to get anywhere near the points you would have gotten, but if you get enough right, you might get a point back, and that might be the difference. You never know. Also, anything you do is going to be a review for the final, so double bonus, right? So any homework you haven't turned, now, whatever you give to me today, in terms of like test or quiz corrections, I'll try to get graded by Monday, and then I'll have my spreadsheet up on my computer. It'll be the most up to date, and you can actually take a break from the final, come up and take a look. Right? You guys understand what I'm saying?
Yeah.
Yes? Okay. All right. Otherwise, you can just hold on to stuff to study from and then turn it in on Monday if you want to do it that way. I'm going to bring snacks for us, and well, for me. No, I'm joking. For all. You watch me eat my snacks now.
Final on next Wednesday or next Monday?
Finals next Monday. What's happening next Wednesday for us?
Nothing.
We're done.
We won't exist as a group after. Oh man, that always hits me afterwards. I'm like, I'll never see some of you guys ever again.
Will you be here for your office hours on Wednesday?
Shit, no. Sorry. On Monday, I'll try to bring an idea of when I'll be in my office, but more than likely Wednesday, I'm going to leave after my first class so I can grade their finals. Does that make sense? Because I won't have anything else to do that day except for grade. So, yeah. But I'll let you know. I'll definitely be like Tuesday, I'll have office hours and such. The day after our test, so yeah.
Oh, will you have office hours Tuesday after 3:30?
I don't ever do, so no. It'll be the same as my normal Tuesday office hours. Yeah. I'm sorry.
What time is that?
So before my morning class, from like 8:45 to 9:15, and before my 12:30 class, so 12 to 12:30. It's all up on Canvas, right?
Here, I think I like completely like just kind of like blacked
Oh, let me
out.
turn off the light.
I think you can just ask.
Guys, if you still have questions, let me know. We're not really, or if you're ready, just head out. I'll be.
Can you I kind of blacked out like on this problem. What is it that I did wrong?
Oh.
How was I looking at it wrong?
Okay. The whole problem is its percentages.
Okay.
And then here you started doing stuff like its means and sigmas. So the formula you want to use here is the one that's got percentages in it.
Okay.
That's the p hat minus p divided by square root of pq over n.
Okay.
This doesn't come into play at all. We didn't know any standard deviations, so we don't need to. We create our own.
Okay.
Square root of pq over n. That's our standard deviation.
If I work with you said with p,
P's,
that you kind of give
that
me an
means
idea.
that this step, the z star is going to have p's in it. P hat minus p. You were trying to force it to be x bar minus mu over sigma.
Yeah,
x,
I know. Okay, thank you.
Sure. Sorry guys, who had a question?
No, no, that's a question.
Real quick. Anybody else had a question? No? Yes.
Can I get the practice paper for chapter, like the notes?
Oh, maybe.
He'll give me answer.
I got this I-square table.
Oh, yes, I already.
You got that one?
For what? For the quiz, it was already, which one?
No, there's no answer key for the quiz. Just an answer.
He'll get paper.
No, he just said he could make corrections on the quiz.
Are you talking about the final exam?
No, they had a quiz on Monday. No, he doesn't give answer keys for the quiz. He's just the corrections.
Yes.
Here we go. This one. Yeah, they've all been.
That's just his signature,
Yes.
right? Yeah, every class. Anytime says anything like.
Oh, yeah. You got time. You got time until the final. You're good.
I wish I could just take like.
Oh, here.
Oh, this cheat.
Yeah. Is that the only?
I could wish for the ability for
Bro,
quiz.
don't do anything. I can't change the time. I can't. You try to take it
Oh, I
against-
see.
No, stop, 'cause it's-
You say bigger shots, bro.
Like I can't even activate the light, dude. This thing is I think it's like a shot.
It feels like the skin is detached from my
That's a problem that you should be asking me about, man.
I wasn't asking, I was just telling
Just
you.
informing me.
Just letting you know. The skin feels like it's detached.
The skin was detached from my body. I wanna be, I wanna be, I wanna have it.
Did it change?
Dude, I'm getting easy on that.
But if I did my, this.
I don't know about chemistry, I don't know about chemistry anymore, dude, 'cause chemistry, because John, the exam on Monday, I was everyone was like shit in my exam, for real. We were the smartest people in my class.
No, sorry.
Yeah, I haven't taken
Go
one.
up that point.
Wait, so they're gonna, what are they gonna?
They're coming into the office hours.
I'm still leaving this with you.
Oh, I don't know. Did you want me to look
You
at it?
missed it.
Alright.
Oh, yeah, I have all two. Yeah, I thought you guys could put this
Oh,
back up.
Sorry, I haven't, I've been like, at my aunt's house.
Alright, so now you're at.
So, hopefully I can gain
What
some
was his,
knowledge.
what was his expectancy?
Oh, there's,
I mean-
there it is. Right there.
2 months ago, they said like 2 to 6 months left. You just have to do 2.
Yeah.
Was it simple or did he go to sleep?
It's like a tough one, because it was Saturday, be like, so it wasn't really fitness.
So I have that you've only corrected one quiz, is that true? You know you can correct
Comfortable, like
everything.
restless, and trying to like move and stuff, it was
For example, you need corrections for test three.
you know, taking care of someone who's like,
What's
not really
your
prepared.
average would go from that
Yeah, so that lasted for 2 days.
to that?
So Saturday
But
morning.
I mean, if you corrected everything,
Did you guys put him in
Monday,
the
Monday.
hospital?
test one, this is
No,
the,
he's on,
so maybe you get,
Oh, so he had a monitor and stuff like
oops,
that.
not there.
No?
I would be sorry.
So how
That'll
did you
take
guys know?
this. I mean, so I don't know if,
No, like, he was still, like, there's still like brain activity.
Yeah?
He just, like, wasn't responsive.
Oh, shit, okay.
Yeah, so he's still like.
corrections are a way to study too.
How'd you do?
And again, even if corrections don't get you up to
That
the
happened on Monday morning.
close enough, they'll get you a bigger cushion.
That's not bad.
Does that make
It was
sense?
a rough
A
2
bigger
days.
cushion so that,
How's his family?
okay.
As
You just, what I would do if I were you is I would do just enough stuff to, do you check?
Yeah.
And you turn it in? Okay, gotcha, you're good.
Maybe just like,
Yeah, I think otherwise,
he wasn't getting enough oxygen.
yeah, I would do just enough homework to be ready for the problems and then do the correction. The corrections would be
I don't know, it's weird.
studying
like,
and
the
directly
nurse said-
increasing your grade.
Like it just, I don't know, the way they described it wasn't like that. I didn't expect it to not be conscious with us for the last week.
Sure. You have to put one list of data in, do one bar stats, get the X bar and the S, then you can make a confidence and only have these two scores because you only have S, right? And then put the other set of data in. Once you get them created, if one is 5 to 7, the other one's 10 to 11, they don't overlap, that's evidence the means are different. If they overlap, the means could be the same, so it's not evidence that they're different. Yeah.
I think your phone is still recording.
It is. This is all exciting stuff.